Hello everyone, we welcome you to Glass Academy Webinars 2023. The theme for this year is Art and Science of Designing Responsibly. Today we have with us Dr. Vishalgarg. Dr. Vishal is the University Chair Professor and Director of the Indorama Ventures Center for Clean Energy at Laksha University. His research interests are in the areas of building energy simulations, smart energy homes, and cool roofs. He was awarded the inaugural Dr. Arthur Roosevelt Urban Cooling Achievement Award and is a fellow of the International Building Performance Simulation Association. He holds a Bachelor of Civil Engineering from MBM Engineering College, Jodhpur, and a PhD from IIT Delhi. Welcome, Dr. Vishal. We are delighted to have you here with us today, and we are looking forward to your presentation. Let's hear from you on the topic, Smart Home Energy Management Systems. Over to you.
Thank you, Anita. And hello, everyone. My special thanks to Glass Academy for giving me this opportunity. Let me share my screen. I'll be talking about a smart home energy management system. And before we jump into the topic, I'll try to cover the background, why we need a smart home energy management system or SHEMS. So if you see the scale of the whole grid and the devices on the grid, you see an enormous variation. We will see a small 10-watt charger at home, all the way from that to approximately 1,000-watt load at the home level, 100,000 level watt at the group of buildings, 1 gigawatt at the plant level, power plant level, 10 gigawatt at the city level, and maybe about of the order of 100 gigawatt when we talk about the grid. So for this whole grid to be sustainable, to be stable, we need solutions at different levels. It's not that we can develop a solution at the city level and then hope everything will work. And it's not that if we develop solution at the charger level, at the device level, it will solve the problem. We need solutions at all the levels. So today we are going to see what kind of solution we need at a home level for saving energy and for demand response. So let us first see what are the elements which are making this possible, which are not just making this possible, but also demanding that there has to be solutions at the home level. The major changes in the technology that we see that are driving the readiness and the need for smart homes are the advancements in IoT, availability of renewable energy in the grid, electric vehicles. So what is happening with low-cost IoT? Now it is possible to connect devices to the internet and remotely control them. With more renewable energy getting into the grid, the availability of power is becoming more varying in the sense that suppose it is more photovoltaic that is being added, then we know that there is more power available in the daytime than in the nighttime. The electric vehicles are also getting connected to the grid now, and that will bring a big change because there will be a huge load on the homes when we are connecting electric vehicles. And we have to see how we are able to manage the charging so that the charging happens during the time when renewables are available. And also the distribution is not overloaded when lots of electric vehicles are connected. So with all these technological developments, we hear about two important things happening. One, we hear about smart cities. We talk about 100 smart cities in India, and we also talk about smart grid. But for both of these to work, the smart cities to be successful and smart grids to be successful, I think the smallest of the loads, electrical loads on the grid, they have to be controllable. They have to be onboarded onto the grid. And that means the 10-watt charger, the appliances at home, and overall the home also has to become smart. So that's the background that why do we need homes to be smart for the success of smart city and smart grid. So what are the overall drivers? Now it is possible to get kits from online shopping places, and we can, get bulbs, we can get fan, we can get speakers, and we can, integrate all this and try to bring smartness into the devices at home. Then there is more disposable income, especially in high income group homes, uh, which is again a big driver. People are willing to spend on these technologies. Uh, of course, these technologies themselves are becoming very affordable. Now, for if somebody wants to buy a LED lamp, which can be controlled by a mobile app, it's very much possible to get this in less than 1,000 rupees. And then we also see a big integration of artificial intelligence happening in our day-to-day devices. Internet of Things we have already talked about, and the cloud computing is becoming affordable and available throughout. With the availability of internet, it's becoming very easy to move the computing from end devices to the cloud. So with these drivers, we see that it's now possible to easily integrate smart devices into homes, and it's not necessary to go for the large scale deployment at a home in one go. We can even do it in phase wise manner. So let us see why the smart homes are important. When we talk about the overall energy performance of a home, then it is a function of how the home has been designed and how it is being operated. We might have a very good design, but if the operations are not good, we might not get the required performance. And even if we are performing it, operating it very well, if the design is bad, then again, we will not get a high level of performance. So the idea here is that both of them have to be good, the design and operations. And when it comes to operations, there is a big difference between operations of a commercial building and a residential building. In commercial building, one has access to high-end technology, which is professionally installed. At the homes, generally it is consumer-grade technology, and the customer install it, in a do-it-yourself kind of manner. Then the second thing, in commercial buildings, there is more access to funds, and it is more affordable to invest in efficiency. Also because there are better returns on investment. Commercial buildings operate 10 hours a day and highly energy intensive. So there is a better return, and therefore there's more interest and affordability in energy efficiency solutions. But when it comes to residential, people are not having enough interest in putting in capex, and also the return on investment is low. So therefore, overall, the affordability is less when it comes to residential. The third thing is that in commercial building, generally there are operators who will manage the services, manage the systems, and try to achieve the desired performance. And they are qualified operators, and they have access to tools and techniques for good operations of the buildings. But when it comes to residences, a person cannot hire an operator just to operate one's home. So it all depends on the occupants. And the occupants might be having knowledge about these equipment and energy efficiency, or they might not have. Even if they have, it all boils down to how much time they are able to spend in managing their services at home. So it is very challenging actually to have high performance homes because of these reasons. And it's easier to get high performance buildings in commercial setup. And that's what necessitates SHEMS, that is Smart Home Energy Management System. So here is one of the definitions. There are several definitions of SHEMS. Here is one of the definitions that I have picked up. It says that SHEMS enable consumers to control and track the use of products and devices, ranging from their lighting, entertainment, appliances, to the EV charging or solar panels, all in one centralized management system. So basically providing customers or consumers control and tracking. The second thing it offers is a variety of energy saving attributes, such as including standby limits to all required devices, grid communication capabilities to enable demand response functionality, utility time of use pricing integration to run appliances or EV charging off peak, and the ability to suggest energy saving actions based on room or home occupancy. So now here you see that it brings in the flexibility, it brings in the ability to respond to the pricing from the grid and run the appliances when the cost is low, and also giving tips to the occupants on how they can achieve energy saving. So here you see the expertise which comes in commercial buildings from professional operators that is coming into the picture. The first one is just giving control and track to the user. The second one is bringing in the intelligence. And the third aspect in SHAMS is SHAMS simplifies your effort to save energy use and allows you to reap the full benefits of home efficiency regardless of your level of personal involvement. So with less involvement and less complication, it brings in all these benefits to the user. So that is what is SHAMS. So SHAMS is not just hardware. SHAMS is the whole system, which includes the hardware, which includes the software, and the intelligence, which analyzes the data and make recommendations. So there are lots of technology and market trends that are happening right now. First is the entry point devices. So we see smart speakers, we see Wi-Fi routers, set-top boxes, which are becoming hubs for the smart homes. Then we see smart home becoming a service. And I think this is very important because we know some of the bottlenecks for adoption of smart home is CapEx. People don't want to spend on the CapEx, and they don't know whether things will be interoperable or not. So they would like somebody to offer them the smart home as a service. And this is quite possible if it is driven by utility, telecom, or cable network providers, because they already have access to the homes and they can provide all the hardware and software and management aspects to the homeowners as a service. We also see that a lot of builders are bringing in smart homes as a part of the standard fitment in the new homes. One of the important things is standardization and interoperability. There are a lot of efforts going on worldwide on standardizing the protocols, as well as bringing in interoperability Basically, what it means that if I buy any device from the market, from any developer or any OEM, I should be able to interface it with other devices and with the software that I am having at my home. So if I buy one thermostat, whatever is the company, it should work with my AC. If I buy any lamp, it should work with the app that I am having and with the occupancy sensor which I have installed at home. So they should all talk to each other and should be interoperable. So this is what is happening now. And as we know, artificial intelligence is getting into the mainstream and help the users take the right actions to save energy. One of the interesting things that we see now is the integration of chatbot into the whole system. So the new generation, they find themselves more comfortable when they chat with the system, or in this case, the home. So they prefer using the chat interface. Say, for example, I can ask my home that what is the current consumption, what devices are on, is there some device which I can switch off and save energy? What was the energy consumption last week? How am I doing this week? So I can put all these questions as a simple plain text into the interface, and I can get results. And this is much more preferred way of communicating as well as controlling uh, devices that is coming up now, thanks to the advancements into chatbots and chatbots getting integrated with the banking, with the uh, ticketing, and so many other things that we are, working with when we are dealing with, and it's making things easier for people to interact. So this is what is happening. And then another big advancement that is happening is in the area of energy harvesting. Why do we need energy harvesting? When we are putting in so many sensors and actuators all around in the home, then for them to work, we need to power them. And we have two options. One, we can put batteries in all these uh, devices, uh, and or we can power them with wire. So both of them are not very much preferred. Wiring is expensive, makes things very rigid and difficult to achieve. Batteries are good, they keep the things wireless, but the problem is that we have to replace them. Even if we have to replace them once in a year, and we have hundreds of such devices, we will eventually be making some replacement every week or so. So uh, energy harvesting makes it possible to have sensors and these devices uh, generate power from the energy that is available around them uh, in the ambience, right? So there is no need to replace the batteries, and there is no wiring required, and they will work perpetually. So again, this is a very important area, and a lot of advances are being made in this area. So besides these technological trends, we also see a lot of appliances that are coming up into the market, which have some kind of smartness built into them. And they they are potential appliances to be used in homes, especially from the perspective of energy saving. So, and smart blinds. So these are the blinds which we can put on windows, and uh, they are controllable, and based on the sunlight and the glare that is possible, uh, it can detect that there is too much sunlight or glare, and it can close, or we can remotely close or open it. Then I'm sure you must be hearing about uh, smart thermostats, and they can control the air conditioning in the home based on the occupancy, based on the outside temperature, based on the set point that is required for the season. It can automatically control and save energy. Then there are smart IAQ devices which can tell what is the indoor air quality, which can also check the outdoor air quality through similar devices placed outdoors. And by comparing them, it can decide when to increase fresh air, when to decrease fresh air, and can also recommend user when is a good time to open windows or go out for a walk or a run. You know. And then there are ACs, uh, which can not only be controlled through voice, but they can also be controlled through app. And interestingly, now IoT-based ACs are being developed, which can help in demand response. So when the user gets a message from the utility to reduce the energy consumption by raising the set point or switching off the AC, and the user participates in that, then the user can get some monetary benefit for doing that. Uh, then smart washing machines, which can not only find out what is the best wash cycle to save energy, but can also be programmed to do the wash when the cost of electricity is less. So we can shift some of these loads to the time when the tariffs are low because of availability of renewable energy. Uh, Again, there are lots of interesting things happening in the area of refrigerators. Uh, so we are getting refrigerators which are not just being energy efficient, but it saves energy by reducing the times uh, people operate their doors, and they are also becoming like hubs for control of other smart home devices in the home. Smart geysers, again, just like air conditioners, uh, the smart geysers can be controlled remotely, they can be scheduled. Interesting thing is that they can also help in shifting loads, meaning hereby that they can uh, they can generate the hot water during the times when the cost of electricity is low and store that hot water for use when the cost of electricity is high, say for example, right? So it can shift the load. Uh, it can also automatically adjust the set point for the hot water depending on the outdoor conditions and the season. Again, thereby saving energy by not overheating the water, and switch off when it is not being used. So a lot of possibilities that we see in geysers. Smart lighting, again, it can be voice controlled, it can be controlled through app, through chatbots. But the interesting thing is that there can be dimming included in the lights. It can also be color tunable. So to help in the circadian rhythm and to help bring in a nice ambience and also reflect the change in the outdoor lighting conditions, these lights can change the color temperature and uh, based on the user requirements or based on the ambience or based on the time of the day, not only giving comfort, but also saving energy. Then to ensure that all these things are integrated, there is a lot of development happening in the area of management systems and monitoring systems. So these are apps or uh, web applications, mobile applications, which help visualize the data, which help track the energy consumption, disaggregate that. The disaggregation can be intrusive, where we have circuit level monitoring or plug level monitoring, or it can be non-intrusive, where we look at the main meter readings and then try to decipher that what devices are on at a given time. So there's a lot of analytics, there's a lot of visualization, there's a lot of uh, inputs that the user can give and control elements that these energy monitoring systems bring in. So again, there's a lot of development happening here. And the interface need not necessarily only be visual. This can also be audio, and this can also be a chatbot style interface and not just click kind of thing. So now we have understood that there is a lot of technological advancements. There is there are a lot of devices that are now there in the market, the systems in place. But what is the energy saving potential? How much do we benefit if we install these technologies? So there has been a lot of research that is going on for more than a decade. And here are some results that I'm trying to put in here from different research that have been done, in various parts of the world. So we see here that technologies like smart thermostat, smart window control, they can save around 10 to 20% of energy. Smart lighting, smart plugs can save up to about 5% energy. And if you put overall smart home, then there have been studies which have shown even up to 20 to 27% energy savings. So there is a huge potential to save energy. Of course, we can't take these numbers as it is because it all depends on the baseline from where the interventions were made. It also depends on the climatic conditions and, of course, what kind of interventions were made. But most of these research works demonstrate that a good amount of energy savings is possible. We need more research in the Indian context to see what is the potential when we apply these technologies individually or when we apply them together as shams in Indian homes, and we need to see how much do we save. One important thing that I like to highlight here is that many of these field studies are not long-term, and therefore we don't know the long-term saving potential. So sometimes what happens when we apply these new technologies, the savings in the near future are very good, but after some time, the novelty dies away and people do not look at these graphs, they do not look at these tips and implement them. So there is always a chance that these savings will taper off and will reduce. I'm not saying they will lead to zero savings in the future, but they reduce. And the initial few days we get very good savings, then we see some degradation and maybe it settles down after a year or so. So there a lot of long-term studies are also required to see the long-term benefits. Now, besides savings energy, another important element where smart homes can help is demand response. So there are devices which can be programmed to operate only when the pricing is less, like say, for example, washing machine, so we can shift the load. Then thermal loads such as air conditioning and water heating can also be reduced or shifted. We can reduce it by changing the thermal settings, like raising the set point for air conditioning for 15 minutes or half an hour. That will reduce the load. Or as we saw in case of geyser, we can preheat the water when the cost of electricity is low. Then we can also schedule the charging of electric vehicles, again, to shift the demand from peak to off-peak. So the smart home can help us in not only energy savings, but it can also help in shifting and curtailment of the demand. But for all these things to happen, we need programs. So internationally, there are lots of programs. There are programs on standards which define minimum device requirement of smart homes, like Energy Star USA, HDB at Singapore. Then there are green building rating or certifications, which understand which assess the performance. For example, smart readiness indicator or smart home building energy building certification program in Germany. Then there are standards, which are alliances or programs to overcome barriers, such as lack of interoperability, data security, etc., like Econet, OCF. And then there are DSM, DR, and energy monitoring programs, uh, like one in SC, California, PowerShop, Australia. So there are lots of international programs which are trying to facilitate the adoption of SHEMS. I'll now shift gears and talk a little bit about the SHEMS research that we have been involved in as a part of RESITE project, which was India-UK joint project where IIIT Hyderabad was the lead, and Oxford Booth from UK was the lead from UK, and Department of Science and Technology India funded the India side. And similar work is now also being done at Lakshya University. So the idea here is to understand holistically what kind of smart home energy management systems have to be developed in context to Indian homes, Indian users, which can bring about the savings as well as demand response. So here, what we did, we first assembled the hardware which will be used in SHEMS, which includes energy meter, smart socket, infrared emitter, window door open close sensor, and temperature humidity sensor. With this hardware, which will go into the homes, and we'll be able to monitor and control the homes and bring controllability to the user. Now the question is, the first thing that was done was to understand what should this interface look like. And we did a survey, and we found that most of the occupants are interested in these 5 type of information: the total energy consumption, appliance level disaggregated energy information. They want energy tips. They want to have some kind of goals and how they're meeting those goals, energy goals. It can be energy consumption per day, energy consumption per week kind of thing. And comparison of their current energy consumption with the historical energy consumption. So we captured that this is the kind of information that people or residents in India, they would like to have through the whatever survey we did. Then we also found that depending on the age, people have different preferences. So young adults, they prefer to see energy consumption information in monetary terms. Middle and elderly age citizens prefer both kilowatt hour and monetary units. And middle-aged citizens generally prefer text-based feedback over chart or graph, which younger adults prefer. So looking at this, we developed some interfaces for the mobile app, which gives energy consumption over the day, different times of the day, over the days, in different days of the week, likewise, which had both energy and cost parameters. Then we also brought in the possibility to see the energy breakup with device such as air conditioners, refrigerators, washing machine. So which device is consuming how much? Then we brought in comparison both within the home, so comparison of this week with the last week, and also comparison with the neighborhood. So how much energy are we consuming as compared to our neighborhood? What is our rank in the homes which have similar size, similar income group, similar location, similar number of people? How many, like say for example, here you see how much the AC is consuming, how many hours the AC is being used. So we get some idea that how are we performing as compared to our neighbors. And of course, we can also see the energy consumption over time, and this can also be device level. And we can also see what is the temperature that we are maintaining in our room. This will give us an idea if we are keeping the rooms too cold or too hot, and thereby estimate the benefit of change in the set point. We also included some interesting possibilities in the SHEMS app, which included energy saving tips. So using data analytics and artificial intelligence at the server side or the cloud side, the system can generate tips, and those tips can be passed on to the user. Like, say, for example, increasing the set point will save you energy, set point of the AC, or the outdoor weather is pleasant, open the window, switch off the AC, or use fan along with AC, it will save you energy. And then we also gave the possibility of automating some of these tips. Like, say, for example, it can automatically change the set point of the AC based on the outdoor conditions. It can automatically understand the user behavior. Like, say, for example, in the third screen, you see that, okay, it seems that you use the geyser from 10 a.m., 8 a.m. to 10 a.m., but you keep the geyser on throughout the day. So should I automate this so that the geyser switches off at 10 o'clock and switches on automatically at 8 o'clock, so that you don't waste energy by keeping the geyser on throughout the day? So like this, not only it helps in the tips, but it can ask the user if it should automate some of them. And if you automate, then you don't have to, worry about managing this manually. It can be all automatically managed. So what we did after we developed consumption per day was about 14.3 kilowatt hour. So like this, we can see how the electricity consumption is distributed in a home based on the major devices. And this, when presented to the user, can help user understand where the energy is getting consumed and try to reduce it, either by changing a device, going for a more efficient device, or using it more judiciously. Or if there is a fault in the device, this is an opportunity to find out and try to fix it. We also looked at the air conditioner and geyser usage pattern during peak summer. So here in the top graph, you see the air conditioner usage of 14 homes, 14 air conditioners when it is averaged. So you can see that the green line gives the probability of AC usage. You can see about 70% probability of AC usage in the night time, and very little usage during the morning hours, and there is some usage in the afternoon hours. And average load in the night time is about 400 watts. This is the total load at that time divided by number of ACs. So you can see that there is more load in the night, of course, less in the morning. We can similarly see the geyser usage. The geyser usage peaks at around 8:30 and 9 o'clock in the morning. And there's a little bit usage throughout the day. Maybe it is not really the usage, but it is switched on and kept on throughout the day. So it keeps cycling, and therefore there is a usage throughout the day. So these are some preliminary results. We are still analyzing and investigating more. But what I want to show here is that smart home energy management system can capture high resolution data, device level data, and we can try to understand what are the consumption patterns. And this can also help us in understanding if there are any faults in the devices, or if the usage is not typical usage that an average consumer will use it. So here you see two interesting graphs. The x-axis in both of them is daily. Sorry, the x-axis is the daily average temperature. The location is Hyderabad, and what we are trying to see is the AC energy consumption in the left-hand graph and the geyser energy consumption, daily geyser energy consumption on the right-hand graph. So as expected, we can see as the daily average temperature goes up, the AC energy consumption goes up. And you can see some outliers, and you have to understand that why these devices are consuming much more energy than what the other devices are consuming for the same location, right? Here you can see with the outdoor temperature going up, the geyser energy consumption goes down again as we expected. But the idea here is that with a lot of data that we are able to collect, we can see what is the relationship which can help us in predicting that what would be the consumption in the future, tomorrow, day after tomorrow, if we have weather prediction. So if we know that tomorrow it's going to be 36 degrees average temperature, so 36 degrees centigrade, then we know what would be the approximate air conditioning energy consumption. And based on that, decisions can be made, decisions such as pricing or incentives for reducing the load, or how much power we have to purchase, the utility has to purchase to fulfill this requirement. Now let us see from the point of view of policy, what's happening in India. So as we know that there is energy conservation building code for commercial buildings as well as residential buildings in India. In the current version of ECBCR, which is also called Eco-Niwas Samhita, there is an annexure on smart homes. Because this is an annexure, this is not mandatory, but this gives some idea that what is being worked upon, and there is a possibility that this might come as a part of the main code in the future, and to bring more information and awareness to the designers as well as to the occupants of what's happening. And in each of them, different aspects have been defined that, like say, for example, in monitoring, it should monitor energy, monitor load, comfort, outdoor conditions. In controls, it should allow or facilitate controls for energy saving, for demand response, for user comfort. Interface should provide trends, it should provide control, it should provide tips. Like this, the different functionalities and the requirements are defined. Then it also defines the minimum functional requirements for smart home. So what all minimum functionality should be there so that a home can qualify for smart home. For each of the aspects like monitoring, control, user interface, grid connectivity, and data sharing, what are the services that the system should offer, and how many devices have to be installed, right? So that kind of information has been given in this annexure, and we hope that there will be some trials. People will try to implement this, and then we will also see the benefit that people get out of implementing SHAMS. In one of the works, which resulted into a roadmap, recommended national policy roadmap for home automation technologies for residential energy efficiency in smart homes. In this report, there is a system that has been proposed, which can help in implementing this smart home as a part of mandate, as a part of a voluntary adoption. But how the whole system should work so that the beneficiary, the end user, is able to get the benefits of the smart home, which includes getting the professional level tips, which includes certified devices, which ensures privacy of the data, interoperability, and then how the beneficiary gets the benefits that the utility wants to provide to the beneficiary for participating in the demand response events. So this whole framework, right from manufacturers, OEMs, to testing agencies, to service providers, to the utility, BE, how this whole framework can work. There is one proposal that has been there in this report, and we hope that this framework or a similar or better framework will emerge such that the ecosystem of smart homes can be developed and people adopt it, the users get benefited, the utility get benefited, and overall we are able to decarbonize and reduce the energy consumption in the residential sector. So that's the whole idea about the shams and this whole framework. I think shams is not just technology, but it is a bridge. It's a bridge. It's a system which bridges technology and individual behavior. It's very important to consider individual behavior also while developing such systems and estimating the benefits that we can get out of it. Thank you.
Thank you, Dr. Vishal. Your presentation was truly enlightening, offering us a glimpse into the future of home energy systems and how we can harness technology to make our homes more efficient. In the fast-paced world that we are evolving right now, I truly believe that understanding and integrating such systems is not only crucial for energy conservation, but also for ensuring a sustainable and eco-friendly future. And I'm sure the webinar undoubtedly enriched our viewers' awareness by equipping them with the knowledge to make informed decisions about their energy consumption and have a lot of learnings to take away today and are also curious to know more, including myself. So I would like to take this opportunity to ask you a few questions.
Sure.
Let me begin with, is smart home energy management system included only during the time of occupancy, or can it be included in the entire design process as well?
Right. So right now, the emphasis is that how we can include smart home energy management systems as a retrofit in existing homes. It's just as a technology and equipment being installed at the homes. But to get the full potential of shams and the real full benefit of this, if it can be incorporated in the design, it will be even more helpful. Like say, for example, at the time of design, if the orientation of the window is such that it will get glare in some time of the day, in few days of the year, then provision can be kept to include an automatic shade in the window design itself, right? Instead of working on huge overhangs or some other ways which might be expensive or which might not be feasible, technically feasible, one can try to incorporate some kind of automation to achieve similar performance at a lower cost. And so this kind of availability of devices and automation gives us a little more flexibility in design. So both ways, it will help in design as well as the design should incorporate shams to get the maximum benefit.
Definitely, sir. Understood. The second question is, how can we future-proof smart homes to accommodate evolving technology and homeowner needs? And how can we ensure that smart home systems are scalable and adaptable to the future technological advancements as well?
Okay, so this is a difficult question. Technology changes so fast that there is nothing like future proofing, right? Every day we see something new coming up. So I would say future proofing will not be possible. But investing into technology, which is based on standards, which is based on open protocols, will help in the sense that generally what happens, the newer technologies that we will see, they will be backward compatible. So if you are taking a new thermostat, say for example, or occupancy sensor in the future, there is a high likelihood that it will be backward compatible and it will work with the older AC or older lights, right? Provided we have not gone for proprietary system, we have gone for standardized systems. And also to avoid getting locked into technology which doesn't work with the future technology. One way is to go for these things as a service. So we don't own it. We take all these things as a service from manufacturer, and then manufacturer keeps on upgrading them and making sure that they all work together. So these are the business models that will emerge. My take is that shams as a service would be a more successful business model than people investing OPEX and maintaining the things themselves.
Correct, correct. Yes, and how can we as architects or designers leverage smart home technology to create more efficient and sustainable solutions when designing at large scale, sir, especially city level urban planning, multi-unit housing solutions, and etc.
Okay, so if you see shams, there are two key players or two key stakeholders in this. One is the homeowner, and another is the utility. So if nobody else is deploying shams, and if I deploy it only in my home, I will get the benefit, right? I will be able to save some energy. I'll get more comfort or whatever I get. However, there is no benefit that the utility will see. One home having some demand response or some energy efficiency will not make an impact to the utility. So the question here is that to get the real benefit of shams, it has to be at scale. So imagine if 1 million homes are participating in a demand response program and they shift their washing machine utilization from peak to off peak, or they change their thermostat settings. So whenever there is a peak load, they increase the thermostat setting by 1 degree. 1 million homes increasing their thermostat setting by 1 degree for half an hour also can make a big difference to a utility, right? So now the question is scale and how we can design homes and these systems in such a way that we can connect them and we can bring the value of scale to the utility. Like I'll give one example. If we want to do thermal storage, it is difficult to do thermal storage at a home level. I cannot make ice and melt the ice at the off-peak time, make the ice at off-peak time using renewables and melt it when there is peak and do the air conditioning in the homes. Homes generally would need air conditioning in the night time. At the night time, there is no energy coming from the photovoltaics. So how can I make ice in the daytime and provide air conditioning in the night time? If I do it at individual home, it is not possible. But if I go for district cooling or kind of a centralized cooling, say for example, there are 1,000 flats, and if you provide centralized cooling for those 1,000 flats, not only because of the diversity, my chiller size will come down drastically, but I will be able to store the heat at the central level and then shift all air conditioning load from the night time to the daytime. So that huge potential is there, and that architects and designers have to think how, when they are doing work at the scale, they can bring in these aspects to decarbonize the the energy.
Absolutely, sir. Yes. And this brings me to our last question for the day, sir. So with respect to our Indian context, what are some considerations to be kept in mind when designing homes for multi-generational households, for example, joint families that include all age groups of users?
Right. So you're talking about homes which have people from different generations, right?
Correct.
Okay. Yeah. So Most of the times I see people focusing most only on technology. Many people, they just get driven by the technology. And I was also one of them. Uh, but when we started doing these field trials, I realized that technology can take you only to a level, not to the end result, right? Not to the highest level that you want. Human aspect becomes very, very important. If the technology doesn't match with the uh, requirements or with the uh, with what people like, it will not work. So we could clearly see that there is a big difference between what kind of interfaces elderly people need as compared to young people, right? So young people, they want to chat, they are okay with graphs. Elderly people, they are happy with interfaces which are simple, which gives them text and not complicated graphs, likewise, right? So there are many different preferences people have. So it is important that we cater to all kind of people. We have to cater not only to the age, we have to also cater to the education level. We have to cater to the culture. We have to cater to the income level. So there might be different preferences for different group of people, and these systems should understand their preferences and work with them. We would like to nudge them. We like to nudge them towards energy efficiency or towards the kind of behavior that will help in demand response, but that can only come once there is acceptance. And acceptance will come once we develop systems which match their requirements. So if you are developing systems where there is a diversity in the occupants, then the system should be not rigid and should be flexible to adapt to the user. And one of the possibilities is that suppose in the app, the user says, this is my age, this is my education level or whatever. And based on that, it automatically gives the interface, which is commonly found to be suitable for that particular group of people, right? So that is one possibility.
That comes to the end of the session, sir. Thank you very much. It was very informative and insightful. So on behalf of all of us at Glass Academy Ethos, I'd like to thank you for sharing your thoughts with us today. Thank you very much, sir.
Thank you. Thanks a lot.